Let's take a look at another absolute extrema problem. This one has to do with revenue and maximizing that revenue, but the price is given in a little bit different form. Here's the question, super busy, lots of information. Remember, when you read it, the first time through, you're going to put yourself in the neighborhood, you put your pencil down. Have you ever heard of anything like this before? Second time through, do you know what they're asking you to find? Have you seen something like this before? Have you done something? Then pick up your pencil and write down some information. So here's the question again. Pause the video. Please write down the key information that you see for this. So remember, 3 times. Neighborhood, what are they asking you? Then pick up your pencil and write stuff down. Okay, now that you've done that, you've got X, the number of blenders that they're actually trying to sell. They're giving you a cost function as well. The first thing we're going to do is solve the demand function for P. Now, the demand function, oddly enough, is here, and it's not written in terms of P equals something. So we're going to have to do something about that. So here we go. X is the number of blenders. P is the price. X, so this is all the information you have written down. Let's go ahead and solve that demand equation here for P. So X equals 5,000 minus 40P. Let's go ahead and add 40P and subtract X from both sides. We do it at the same time so that we can do it a little quicker. Now we're going to divide everything by 40. When we do that, P is equal to 5,000 divided by 40, which is 125, minus 1 over 40x. That's the price. P is the price in dollars per blender. Now that we have that, that's what we just found. And we're going to answer the second question. We're trying to maximize the revenue. Well, to maximize the revenue, this is the cost function, not revenue. So we're going to need to find something, some function. Revenue is quantity times price. And if you remember, X is the number of blenders and P, price, is what we just found. So the revenue function with respect to X is going to be X times the price, 125 minus 1 over 40X. When we do that, go ahead and multiply it out. 125x minus 1 over 40x squared. We're now looking for the critical values. We have, to do that, we got to have a derivative. So let's take the derivative of the revenue. So we get 125 minus, the 2 comes down, divides out with that 40, so you get 1 over 20x. That's the derivative. We're going to set it equal to 0 to get the critical values. Add 1/20th x to both sides. Multiply both sides by 20. And when you do that, you get 2,500. Now, that is exactly 1 critical value for all our real numbers. And so we can use the second derivative to show whether or not this is a max or min. And we're going to test it using concavity. So let's find the second derivative of the revenue. Here's this function here. And derivative of the constant is 0. Then we get the coefficient. That is a negative number less than 0 for all real numbers, which means that we have a max, concave down, so we get a max at our critical value. And our critical value is 2,500. They're also asking what price results in that maximum revenue, so we're going to have to go find the price. So price is equal to 125 minus 1 over 40 times 2,500, and that gives us 62.50. So we can write our final solution then. You should charge $62.50 per unit, and remember they're blenders, $62.50 per blender to maximize revenue. Remember, they're not asking us to actually find that max revenue here. They're just asking us what price we should charge. Now they're asking us what is the maximum revenue. Well, we know that X is 2,500 is where the max occurs. So let's substitute that into the revenue function. And the revenue we had on a previous page, 125 times the 2,500 minus 1 over 40, 2,500 squared. Grab your calculator and you get 156,250. We can now write our final solution. We get a maximum revenue of $156,250 when selling 2,500 units at $62.50 per unit. And that's all of the information altogether. I know some of you really hesitate to want to, when you come down here, putting all of this information together in one place. But I recommend that you do that because that makes the answer complete and whole. And we like it better that way. So hope you're having a great day.